Okay. A delivery man starts at the post office, drives 40 kilometers north, then 20 kilometers west, then 60 kilometers northeast, 45 degrees above east, and finally 50 kilometers north to stop for lunch. Find his net distance and displacement vector. So what we'll do, make sure, yeah, all right. What we'll do is you draw an axis, so just northeast, southwest, and then I have the post office starting at 0, 0 here, and then just draw. We're just gonna draw out his route. So first he goes 40 kilometers north. 40 kilometers north. I think it was 20 west. Yeah, 20 kilometers west. And then I think it was 60 northeast. Yep. And then 50 kilometers north. Okay. All right. I'm going to draw the 45-degree angle here. And then 50 kilometers north, which I'm going to have to make kind of stubby here because I made this a little bit too... made the scaling a little bit too bad, but that's fine. And so then we have also this is slanted because I'm drawing with a mouse. I'm not good at it, so but this is meant to be straight. But then you can just draw the vector, which is where you're starting to where you're ending. I'll get the line tool. Oh god, I hate that. All right, that's fine. All right, and then you can just then we can draw the x component, which I probably drew too big, but that's fine. And the y component. Yeah, I drew the x component too big. That's fine though. Yeah. All right. Anyway, and then you basically what we have to do is this angle here would be the well, I don't want to make it green. This angle here would be the direction that they're traveling in, and then the length of this blue line, which is the vector, the displacement vector, would be the magnitude of the vector, which would be how far they traveled relative to where they started. So the first thing that we want to do is we want to find the x and the y components. So I'm going to start with the y components. And so for the y, they start by going up 40. And then they go north 40. They start by going north 40. And then they go kilometers. I gotta add kilometers because he'll kill us if we don't. And then and they the next time the y-axis changes is when they go 60 kilometers northeast. So in order to find how the y component changes there, you're gonna have to do a little bit of trig here. So you have 60 kilometers as the hypotenuse, and 45 degrees is the angle they're traveling at. So in order to find the y component, that's just going to equal basically sine of 45 degrees, which is the 60 degree. The 60 is like the vector of them traveling northeast, and then they're traveling at a 45-degree angle. And because this is the right triangle, you can do sine of 45 degrees equals y over 60, which is opposite over hypotenuse. And so then y equals 60 times sine of 45 degrees. And then you can do that in calculator. I'm pretty sure it's just going to be 30. But I'll do it on my calculator on google.com because I don't have it with me. So sine, and I'll make sure it's in degrees, by the way. Sine 45 times 60. Okay. It's in radian, my bad. Okay, I didn't realize that. All right. That's not. Okay. Times 60, that's not going to be 30. So, yeah, 42.426. This is why we do this. I just assumed it would be 30 for both. I was wrong. 42.426. And then x is going to be 60 times cosine of 45 degrees. And I want to check. Yeah, okay. And then that's just going to be cosine 45. Yeah, square. I think it's just square root 2 over 2 for both of them. And then that's 40. Yeah, so yeah, it'd be both of yeah. I don't know my radians to degrees off the top of my head, but I figured it was probably square root 2 over 2 for both of them. So yeah, they're going to be the same, which makes sense because it's split evenly between north and east. So so for the y, they're traveling 42.426 in the positive y direction, or the north. So you start with going up 40, and then you go or north 40, then you go north 42.426, and then kilometers. Make sure to add kilometers. And then you go north 50 kilometers. And then in total, you have 82.426. That's going to be 132, I think. Yeah, 132.426 kilometers is going to be the total traveled in the y direction, which I think is, we denote with the j. And then for the x direction, the first time you travel anywhere in the x direction, you go 20 kilometers west. And since west is on the negative x-axis here, it's going to be negative 20 kilometers. So we start by going negative 20 kilometers. And then the only other time we travel along the x-axis is when we go 60 kilometers northeast. And that's going to be, okay, that's going to be what we found here, plus 42.426 kilometers. And that's going to be vector x is going to be 22.426 kilometers. And then I'm going to redraw the triangle, the vector for like the total displacement here. So I'll get the this, and then get the green. That's yeah. Okay, it doesn't need to be perfect, but I have the option to make it perfect, so I want to. And I think they're just all blue. It's fine. Yeah, there they are, all blue. It's fine. It's fine. This is okay. This is let me fix this. Okay, I fixed it. All right. So this is the vector, and we have the x, or this is the y, but we have the y distance, total y distance traveled as 132.426, 0.426 kilometers. And this is the x. We have total distance traveled as was it 22.426? Yeah, 22.426 kilometers. And this is the right triangle. So to find the total displacement here, basically all we need to do is for the magnitude of the vector, we would just need to do the hypotenuse, which is c squared equals a squared plus b squared, and then we just take the square root. So the Pythagorean theorem, basically. We'll say displacement squared equals x squared plus y squared which means displacement magnitude. This is what this means, magnitude. Displacement equals the square root of x squared plus y squared. And then you would just plug in 22.426 and 132.426. I'm just going to do that off camera. And for the magnitude, we get 134.311 kilometers. The final answer here is in meters. So to do that, you just convert it to meters. And also it has it in scientific notation. They don't use sig figs here, but okay. Either way, it's just scientific notation. I don't know if that's gonna be a thing for this class. I don't think it is. I don't think he doesn't seem to care. And it didn't specify which. I know meters is the standard, but it didn't specify if it wanted kilometers or meters here. So I figure that it's probably fine either way. And then to get the direction, basically, which is this angle right here, basically, or this angle, if you're looking at the original model we drew, it's just this angle, which is this one. These two are the same angle. You use tangent. So tangent of theta equals opposite, which is y. 132.426 kilometers over adjacent, which is x, 22.426 kilometers, and then you just do arctangent, and you have arctangent on both sides, and then you have theta equals arctangent of 132.426 kilometers over 22.426 kilometers. And you just plug this into a calculator. And 32.426. I also got my calculator off camera because I hate using the Google one. All right, I have it in radians. Okay. Yeah, I don't know why physics is at least in my experience, is almost always gonna be in degrees. But radians, in my opinion, is just better. But anyway, for your direction, you have theta equals 80.39 degrees. And if you look here, it's 80 degrees. So yeah, that'll be your direction. And then finally, it wants the total distance traveled. To do that, it basically it doesn't matter. Here, let me figure. All right, so for distance, you just want to add all like the 40 plus 20 plus 60 plus 50, and that would be the total distance that they traveled. Um, and this again, the answer is in meters. I don't know if that's what would be requested of us, like if this were asked. Um, but generally, it'll be specified, or it'll be multiple choice. What unit you want to use, so that's fine. Anyway, I hope this helped. If not, I can go over it with you like on call or something. It was it's kind of awkward using drawing with a mouse doing this. I haven't done it in a long time. So you know, if there are probably better mediums to do this through. A lot of the time I would do it via paper and just record with my phone. I just didn't feel like it. Uh, but yeah, let me know if you need anything else. But that's how you would do the displacement, direction, and magnitude.